This is the third video in the conversion series. I'm Brendan, and I'm going to try to help you understand a slightly more complicated type of conversion. So again, I'm going to start with a quick review of the previous types. So let's say I want to convert 87 liters. Actually, we're going to do meters here, to centimeters. So if I have 87 meters, set up my little fence. At this point, should be second nature. Meters on the bottom, centimeters on the top. I realize my conversion factor is 10 to the negative 2. 1 in the top here. So this becomes 87 divided by 10 to the negative 2. To get rid of a negative exponent, you just move it to the numerator. So this becomes 87 times 10 squared centimeters, or 8,700 centimeters. Alright, so that's pretty straightforward, just moving it over 2 decimal places. Now let's go through a different type of example. Let's say we had a square. This is my square sheet. And we'll say each side of the square measured 1 meter in length. So this side is 1 meter, and this side is 1 meter. And I wanted to figure out the area of the square. Well, we know the area of a square, any kind of rectangular shape, is length times width. So this would be 1 meter times 1 meter, or 1 meter squared. So let's say, okay, so this is 1 meter squared. How many centimeters must it be? Well, you probably know from your earlier classes that 1 meter is equal to 100 centimeters. So you think, okay, well, if this is 1 meter squared, my area must then be 100 centimeters squared. So that logic is actually completely wrong. So even though it probably made sense as I was explaining that, this is 100% not true. Do not assume that. Do not make that mistake. Let's see why. Well, if each side of this is 1 meter, we can also describe it in terms of centimeters. So 1 meter we know is 100 centimeters. If that side's 100 centimeters, this side is also 100 centimeters. So if we want to find out the area of this would be length times width, or 100 centimeters times 100 centimeters. So we actually get 10,000 centimeters squared. So it doesn't really make a lot of sense. How does that work, Brendan? 1 meter is 100 centimeters, but 1 square meter is 10,000 centimeters squared. Well, let's this is kind of the example, the proof that it doesn't work, kind of a proof by example. So let's show you how these would apply in conversions. Let's say we wanted to convert 1 meter squared to 100 centimeters squared in an actual conversion problem. Again, same general process to start. We start with 1 meter squared. We set up our little fence. We want meters squared to cancel out. For now, though, I don't have a conversion factor between centimeters squared and meters squared, so I'm just going to put centimeters and meters for now. Prefix for centi, 10 to the negative 2. And then what I have to do in order to get these units squared in here is I actually have to square the whole conversion factor. So I'm squaring basically this whole thing in here. And if I rewrite it down here, I'll find that 1 meter squared times, once I square the conversions, 1 squared is 1 centimeter squared, 10 to the negative 2 squared. When you have exponents raised to exponents, you want to multiply them. So this actually becomes 10 to the negative 4th meters squared. And we can see now that our meters squared can cancel out. So this becomes 1 divided by 10 to the negative 4th centimeters squared. And dividing by a negative exponent, you can just bring it to the top. So this becomes 10 to the 4th centimeters squared, which is, in fact, 10,000 centimeters squared. Moving down here, we're going to go ahead and try another conversion. Let's try to convert, switch to the thinner pen. I think it's a little easier to read. But let's convert 2.5 millimeters cubed to meters cubed. So again, start with the unit and the number that are given together. Set up my little fence here. I know I want millimeters to cancel out. I want to end with meters. So I set, make that look more like an M. So I set that up right there. I know the conversion factor for millimeters is 10 to the negative third. In millimeters gets a 1. But again, I can't cancel out millimeters with millimeters cubed. Millimeters cubed is a unit of volume. Millimeters is a unit of length. You can't cancel out 3 dimensions with 1 dimension. It just doesn't work that way. So what I have to do is cube this whole conversion factor. I'm going to rewrite it down here. 2.5 millimeters cubed. Now, the 3 gets distributed in everywhere. When you multiply exponents, this becomes 10 to the negative 9th meters cubed over 1 millimeter cubed. At this point, the millimeters cubed can cancel and I end up with 2.5 times 10 to the negative 9th meters cubed. These can go a little bit more complicated. You can do multi-step conversions with these, so we're going to do one example of those. As we learned in the last video, multi-step conversions are necessary in the metric system when going between 2 or more units which both have prefixes. So let's try this. Let's try to convert from 97.2, whoops, close that, cubic centimeters to cubic micrometers. Same process as before. It should be pretty intuitive what you're setting up at the beginning. 97.2 centimeters cubed. Again, we want centimeters to cancel out, centimeters cubed to cancel out. So I put centimeters down here and meters up here. Prefix for meters, 10 to the negative 2 over 1. And then I have to cube this whole prefix, this whole conversion factor, because I need centimeters cubed to cancel out with centimeters cubed. Set up another fence now because I have to do an additional conversion where I need to cancel out the meters cubed, which I've just formed. Prefix for micro, or conversion factor for micro, 10 to the negative 6. 1 goes up here, and again I have to cube this conversion factor. So I distribute the cube, multiplying it to each exponent, so this becomes 10 to the negative 6 meters cubed over 1 centimeter cubed times 1 micrometer cubed over 10 to the negative 18th meters cubed. You can see centimeters cubed cancel out, meters cubed cancel out, bam. So what I'm left with is 97.2 times 10 to the negative 9th, 10 to the negative 6 over 10 to the negative 18th. I know I can subtract exponents, so negative 6 minus negative 18. It's like negative 6 plus 12. Go up from negative 6 to 0, up 6 from there to 6. So this becomes 97.2 times 10 to the 6th. And that's how you would perform that type of conversion.